Hi everyone, this is Srikanth, Assistant Professor of EEE Department. In this session, I am going to discuss some problems on mesh analysis. Mesh analysis is the application of Kirchhoff's voltage law. Here, by using the Kirchhoff's voltage law, we are going to calculate the mesh currents in the given circuit. So, let us go with one problem on mesh analysis. Ohms, 4 ohms, 6 ohms, and 3 volts. This is the circuit which is given and asked to calculate the current flowing through 4 ohms. Current flowing through 4 ohms by using the mesh analysis. So here, once the circuit is given for the mesh analysis, first we need to identify how many meshes are there. Mesh is nothing but it is a closed path which does not contain any inner loops. So here we are having two meshes, that is, this is the mesh 1, mesh 2. Two meshes we are having, and in order to get the currents in the meshes, first we need to assume certain parameters. One is current will have the magnitude and the direction. So we have to assume the current direction and magnitude. For current direction, for all the loops, we have to consider one direction so that is easy to write the Kirchhoff's voltage law. So here current direction, I am considering that the current is in the clockwise direction. Current is in the clockwise direction. This is the current directions, clockwise directions. And the magnitudes, the mesh 1 current is considered as I1 and mesh 2 current is considered as I2. When we are considering the I1 and I2 are the magnitudes, now we have to start writing the KVLs. While writing the Kirchhoff's voltage law equations for any mesh, we need to assume that that particular mesh current has higher magnitude. That particular mesh current has higher magnitude. So now let us write KVL for loop 1. KVL for loop 1, that is minus 10. Here current is entering the negative terminal of voltage source. That's why we are taking minus 10. And voltage drops, we are considering it as positive, plus here the voltage across 2 ohms is 2 into I1 plus 2 into I1 plus 4 into, here this is the current which is flowing in this particular direction, I1, and I2 is the current which is flowing in the opposite direction. But our assumption is the current is in the direction of mesh current, because the mesh 1 current has higher magnitude. That means we have to write the equation as I1 and I2 is in the opposite direction, so we have to write it as I1 minus I2. I1 minus I2 is equals to 0, because algebraic sum of voltage in a closed path is equals to 0. Now here 4 plus 2 6 I1 minus 4 I2 equals to 10. This is our equation number 1. Now let us go with KVL for loop 2. KVL for loop 2, that is here 4 into, here I2 current has higher magnitude, so we have to write the equation as I2 minus I1 plus 6 into I2 plus 3 is equals to 0. That is minus 4I1 plus 10I2 equals to minus 3. This is our equation number 2. By solving equations 1 and 2, by solving equations 1 and 2, we'll get the I1 and I2. 2 amperes, 1.5, sorry, 0.5 amperes. So we got I1 as 2 amperes, I2 as 0.5 amperes. Here we need to calculate the current flowing through 4 ohms in this particular direction. So I is equals to, in this particular direction, that is in the downward direction, I1 is the current in the downward direction, I2 is the current in the opposite direction. So I is equals to I1 minus I2, which is equals to 2 minus 0.5, which is equals to 1.5 amperes. This is our current flowing through 4 ohm resistance. Next we'll go with the next problem, that is 6 amperes, 4 ohms, 2 ohms, 6 ohms, 8 ohms, 5 volts, 10 volts. This is the circuit which is given, and now we need to calculate the current flowing through 4 ohms and 6 ohms. So for calculating current flowing through 4 ohms and 6 ohms, that is, this is Ix and Iy. For calculating Ix and Iy, we need to calculate the mesh currents. So for calculating the mesh currents, first we need to identify how many meshes are there in the given circuit. Here we are having, this is the mesh 1, mesh 2 and mesh 3. These are the 3 meshes we are having. So the first mesh loop current, this is I1, this is the direction I2, clockwise direction only I am considering, I2 and I3. Now KVL for loop 1. Here we are having a current source in it. We are having a current source in it. So we cannot write the KVL in loop 1. So KVL is not possible. KVL is not possible. But how to find the current? Based on the current direction. Based on the current direction, we can get the value of I1. We can get the value of I1. So here current I1 and 6 amperes are in the same direction. So I1 is equals to 6 amperes. I1 is equals to 6 amperes. Now let us write the KVL for loop 2. KVL for loop 2. Now KVL for loop 2, that is 4 into I2 minus I1 plus 2 into I2 plus 6 into I2 minus I3 is equals to 0. Here 4 into I2 minus, sorry, here one more source is also there. We have to add the 5 volts. That is, after 6 ohms, there is a 5 volt source that is entering the positive terminal. So we have to take it as plus 5 is equals to 0. 4 into I2 minus I1 is equals to 6 plus 2I2 plus 6I2 minus I3 is equals to minus 5. Here 4 plus 2 6 plus 6 12I2 minus 6I3 is equals to minus 5. 6 4s are 24 plus 24, which is equals to 19. That is 12I2 minus 6I3 is equals to 19. This is our equation number 2. This is our equation number 1. So we got the second equation only in terms of I2 and I3 because we have substituted the I1 value. And now KVL for loop 3. So here when we are writing the KVL for loop 3, current is entering the negative terminal of minus 5 volts, minus 5 plus 6 into here we are writing KVL for loop 3 or mesh 3. So when we are writing KVL for loop 3 current has higher magnitude, I3 minus I2 plus 8 into I3 plus 10 equals to 0. That is equals to minus 6I2 minus 6I2 plus 8 plus 6 14 I3 is equals to 10 minus 5 5 plus 5 if goes to the right side will become minus 5. Minus 6I2 plus 14I3 is equals to minus 5. This is our equation number 3. Now I1 has 6 amperes which is already there. By solving equations 2 and 3, by solving equations 2 and 3, I2, I3, 1.78 amperes and 0.409 amperes. So now we got I2 and I3 as 1.78 amperes and 0.409 amperes. Now Ix is equals to I1 minus I2, because Ix is in the downward direction, so which is in the direction of I1. So 6 minus 1.78, which is equals to 4.22 amperes, and Iy is equals to I2 minus I3, which is equals to 1.78 minus 0.40, which is equals to 1.78 minus 0.40, that is 1.38 amperes. Now we got the Ix and Iy for the given circuit. Now we'll go with the next problem. This is the different problem which is having 3 loops and all the meshes are connected to each other. That is, let us consider it as 20 volts, 4 volts, 3 ohms, 5 ohms, 10 ohms, 8 ohms, 6 ohms. Now here we are having 3 meshes, and we need to calculate the currents flowing through 5 ohms, 10 ohms, and 8 ohms. Ix, Iy, Iz we need to calculate. So for calculating Ix, Iy, Iz, first we need to check how many meshes are there, and we have to give the current directions as well as the magnitudes. So here let us consider the current direction is in the clockwise only, and let us consider the current values as I1, I2 and I3. Now let us write the KVL in loop 1 or mesh 1, we can also call it as. Okay. So now when we are writing the KVL in loop 1, the current is entering the negative terminal of voltage source, that is minus 20 plus 3 into only one current is flowing, I1, plus 5 into, here we are assuming that I1 has higher magnitude, 5 into I1 minus I3 plus 10 into I1 minus I2, which is equals to 0. So that is equals to 3 plus 5, 8 plus 10, 18I1 minus 10I2 minus 5I3, which is equals to 20. This is our equation number 1. Now KVL in loop 2. KVL in loop 2. Now when we write the KVL in loop 2, that is 10 into I2 minus I1 plus 8 into I2 minus I3 plus 4, because current is entering the positive terminal of plus 4 is equals to 0. That is minus 10 I1 plus 10 plus 8, 18 I2 minus 8 I3 is equals to minus 4. This is our equation number 2. The next one is KVL for loop 3. KVL for loop 3, that is 5 into I3 minus I1 plus 6 I3 plus 8 into I3 minus I2 is equals to 0. That is minus 5 I1 minus 8 I2 plus 8 plus 6 14 plus 5 19 I3 equals to 0. Here no voltage source in this particular loop, so after the equals no value will be there. This is our equation number 3. By solving equations 1, 2 and 3, by solving equations 1, 2 and 3, we'll get I1, I2, I3. Now we got the I1 value as 2.5 amperes, I2 value as 1.79 amperes, I3 value as 1.41 amperes. Now we got the I1, I2 and I3. So we can get the Ix value, which is equals to I1 minus I2. Sorry, I3. 2.5 minus 1.41, which is equals to 1.09 amperes. Iy is equals to I1 minus I2, which is 2.5 minus 1.79, that is equals to 0.71. Amperes. And Iz is equals to I2 minus I3. I2 minus I3, that is 1.79 minus 1.41, which is equals to 0.38 amperes. These are the Ix, Iy and Iz values in the given circuit. Next we'll go with the next problem. Let us consider 4 ohms, 6 ohms, 8 ohms, 10 ohms, 12 ohms. These are the This is the circuit which is having the four number of voltage sources. Number of sources are increasing because the mesh analysis is having the advantage of calculating the currents in the meshes even though we are having n number of elements, n number of sources. So here we are taking the four number of sources with five resistors, and this circuit consists of three meshes. This is the mesh 1, mesh 2 and mesh 3. So for each mesh, let us give the current directions, that is I1, I2, I3. If we apply KVL in loop 1, KVL in loop 1, current is entering the negative terminal. So minus 20 plus 4 into I1 plus 6 into I1 minus I2 plus 2 is equals to 0. That is equals to 4 plus 6, 10 I1 minus 6 I2 equals to 18. This is our equation number 1. Now KVL in loop 2, KVL in loop 2, that is minus 2 plus 6 into I2 minus I1 plus 8 into I2 plus 10 into I2 minus I3 plus 4 is equals to 0. So here 6 plus 8, 14 plus 10, 24 I2 minus 6 I1 minus 10 I3 minus 2 plus 4 plus 2, which is equals to minus 2. This is our equation number. And a 6 I1 plus 24 I2 minus 10 I3 equals to minus 2. This is our equation number 2. Now let us write the KVL in loop 3, that is minus 4 plus 10 into I3 minus I2 plus 12 into I3 plus 5 equals to 0. That is equals to minus 10 I2 plus 22 I3 equals to minus 1. This is our equation number 3. By solving equations 1, 2 and 3. By solving equations 1, 2 and 3, we'll get the I1, I2 and I3. 2.11 amperes, 0.59 amperes, 0.198 amperes. These are the three mesh currents we got for this particular problem. Now we'll go with the next problem, that is Here, this is, let us consider 20 volts, 4 volts, 5 volts, 3 ohms, 6 ohms, 9 ohms, 12 ohms, 15 ohms, 18 ohms. Here, this is our circuit which is given. Here, there is a, in every mesh, there is a voltage source. This is a different case which we are going to get. Now, let us write the KVL in the meshes. Let us take the current direction as clockwise, I1, I2, and I3. Here, KVL in mesh 1 or loop 1, KVL in mesh 1, that is minus 20 plus 9 into I1 plus 6 into I1 minus I3 plus 12 into I1 minus I2, which is equals to 0. That is 9 plus 6, 15 plus 12. 15 plus 12, 27 I1 minus 12 I2 minus 6 I3, which is equals to 20. This is our equation number 1. Now KVL in mesh 2. KVL in mesh 2, that is 12 into I2 minus I1 plus 15 into I2 minus I3 plus 18 into I2 plus 4, which is equals to 0. That is minus 12 I1 plus 12 plus 15, 27 plus 18, 45 I2 minus 15 I3 equals to minus 4. This is our equation number 2. Now KVL for mesh 3. KVL for mesh 3, that is 6 into I3 minus I1 plus 3 into I3 plus 5 plus 15 into I3 minus I2. Because we are writing the KVL for mesh 3, loop 3 current has higher magnitude. So minus 6 I1 minus 5 I2 minus 6 I1 minus 5 I2 plus 6 plus 3, 9 plus 15, 24 I3 equals to minus 5. This is our equation number 3. By solving equations 1, 2 and 3, 1, 2 and 3, we'll get the I1, I2, I3. Now we got the I1, I2, I3 values as 0.8, 0.13 and 0.02 amperes. In this session, we have discussed several problems on mesh analysis, and we have also calculated the currents flowing through different elements by using mesh analysis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.